Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is going to continue to look into object-oriented programming in C++. So we've already covered the chapter on just getting data encapsulation and data hiding going. So now we're just going to push forward into operator overloading, inheritance, polymorphism, virtual functions, those kind of things, static variables, and those kind of things. So here's the quick review. I have this circle class. I remember I did this for the last lecture. So if I have a circle class, I have to think, well, what kind of attributes make up a circle? And say, when it comes to the abstraction that you choose, you can do all sorts of crazy stuff. And in this case, maybe I went a little beyond what you might have anticipated originally, because I'm like, I include an X and a Y position in space for the center of the circle. And then I also include the radius. And maybe all you think about it is a radius, but I was just, well, why don't we just make this a little bit more complex? So we have an XY position and a radius that we can apply. And then from there, because I have three member variables, an X, Y, and a radius, I have a get and a set method for all three of those things. So 6 total functions. And so notice they're all double data types, so they all return doubles for the gets. They're all const because they're not modifying the object when I do this. All 3 of the gets, and then all 3 of the sets bring in a new value and then change the value inside of there, and it's a void data type because I don't need to return anything because I'm setting the data stored inside of here. And so I also have functions for get area, get perimeter, and you can call it get circumference, but if we're going to maybe advance this and make this for more than one type of shape, maybe perimeter is a better answer for that than circumference. And then, of course, the constructor idea of allowing me to construct an object in one line of code where I can guarantee that the object, when it's initialized and set up, is everything inside of it is initialized to at least something of value, and it's up to me, on the other end of the programming, to make sure I supply the correct arguments for that. And so that is it for the .h side. This is the way that it looks for the header side of things. Notice there's no actual code. This is almost like a prototype, right? All the prototypes for all the functions, but it's basically like I think we call it a header, but it's like a class prototype in a way because it provides all of the API, the entire API for the circle class. And then the implementation, defining all the functions, goes into a separate file called circle.cpp. And the gets and the sets are very simple. Get returns X, sets return, or just set. And I just had to be careful to do little equals big when it came to the uppercase characters here, just to make sure everything got appropriately set. Get area is pi r squared, and perimeter is 2 pi r, right? So 2 pi radius. And I supplied pi myself up here. I went and looked up how many digits can I get before it doesn't matter anymore with the double data type, and this is as far as I could get. So the gets and the sets, and so the only confusing thing might be the constructor. Remember, the constructor has different constructs, literally. It doesn't have a return type. The function name is the same name as the class type itself. And in this case, I'm passing in the x, the y, and the radius because those are the 3 member variables I need to modify. And remember, again, you don't always have to have a 1-to-1 ratio. Like if I had a tic-tac-toe game and I wanted to initialize how many turns have been played, well, I don't need to pass a 0 in through the constructor. I can just set it to 0 inside of the initializer list. And notice I have this. This isn't like Java or other languages where you put the code inside the curly braces or inside the block of code. Using the initializer, the initializer list here, you set everything up in order as you see it from top to bottom, and you set it up with the values. And it's just so that you don't initialize everything twice. Because if the initializer list is one of those things that C++ can go ahead and actually initialize data one time over inside of here, even if you don't supply stuff. And then if you go ahead and you say, oh, let's do it a second time, well, that's inefficient, right? It's wasteful. And especially if you're running thousands of these things over time, it's wasteful, and it's taking a lot of your time. Video games especially. I need some tight, quick code, and that ain't it. So I want you guys to use initializer lists because that's the way things are supposed to be. But then that covers setting everything up. The .h file has all the functionality, private data, public functionality to access the data how I see fit, and then the implementation in a circle file for CPP, and then this uses the circle or the main file uses circle.h to do all the work. And when I run this program now, you can see with these values, the circle's area pi r squared, 16 pi, that looks about right. Circle circumference 8 pi, that looks about right. This is the, yeah, so yep, about right. And so now this is where we can start our discussion of this new chapter stuff, because I wanted to be able to do something like this, where I want to just say print C, which is the circle object, and have it print just the xy coordinates and the radius, because I can calculate all the other stuff, but I want to override this. And this, so this will take a little effort, and we don't need the .h file anymore, at least for the moment. And so I can drag this over and we can get going. And to do so, this is the most complicated of all of the operators that we can overload, because there are many things that we can't do, like plus equals and equal, like even, well, equals will work out, but there are operators that I'm not allowed to try, and this is just one of them. And so we're just showing you the basics here for the engineering course, but there are 20, 30, 40, I can't remember how many different operators we can overload. We don't have to, because that would be ridiculous to have to overload 20, 30, 40 operators. But we do have to overload the ones we want to use. In this case, I'm just doing this because I want to show you how it works. So this is input-output capabilities. So being able to output to a stream is a very big deal. It's just for any object that is not a base type. So this insertion operator uses what's called a stream, just like the CIN and COUT objects did. And so we can use the properties of an output stream to do the work for us. And so coming back, we will need that .h file after all here. So this is, that's iStream. Hold on, this is it here. Yeah, let's bring back that .h file over here in a second here. All right, so you can see it's a big deal here. This is the implementation of this function, and my goodness, it's really complicated. It says operator, so we're not used to using taking over operators, but it is an operator just like plus and equals and minus and all the other ones that we want to take over. So this is complicated because what we see here, oh goodness, can't I get everything in one? Here we go, is something like this where the left-hand side of this operator is who knows what, right? You would think it's a string, but it's actually the cout, which is a stream. So the left-hand side object of this thing is a stream. The right-hand side of this operator is the object, the circle object. So you can see where this starts to come from. And it's complicated because here's the operator, and it's presumed the first parameter to this is what's on the left-hand side. So like I like to use LHS and RHS, or in this case OSTR for this kind of stuff. And so you can see that on the left-hand side of this operator is supposed to be a stream. On the right-hand side, the next one is a const complex number, or in our case, a const circle reference. And so we're going to put that over here on the right-hand side, because that's what we see. Again, I'll just get rid of this, just kind of bring it back a notch. Left-hand side stream, this, and then when it returns the stream, and that's why I'm allowed to chain these things together. If it didn't return the stream after I throw the information into it, I could only do one cout per line. I could only do cout this, and then I could do cout C, and then I could do cout C end line. I would have to do everything one at a time, but because of the way this works out, the architecture of this, I can do this many times over. And so coming down to it, kind of how we're setting things up. OStream reference operator, arrow, arrow, OStream reference, I use OSTR, that's my way of doing things, and then const circle reference RHS for right-hand side. And so you will see this error pops up and it goes too many parameters for this kind of function. And say if you don't appreciate the complexity and the ridiculousness of C++ by now, just wait until advanced C++. But what happens is that there's like 3 or 4 different ways we can assign and use the different operators in C++, which means there's 3 or 4 different syntaxes, or what's the plural for syntax, or just syntax. And it gets confusing because a lot of times you don't remember which one is which, and you just have to sometimes have the compiler, in this case, tell me what to do. And we'll see this keyword here in a minute called friend, and that immediately fixes up the red squiggly and brings us back into a more friendly green squiggly, which means I just haven't defined the function yet. I've declared it, I've made a prototype for it, but I haven't gone ahead with anything more concrete. So let's do exactly that. Let's make this a little more concrete. Let's make it so we can actually run this as we want to. So what's cool is, again, I can steal this guy, right-click on it, quick actions, create, and there it is. It generates all this cool stuff for me. Oh, red, it turned red. OStream is not defined. Where was that a second ago? Was that screaming at me before? I just need to include IOStream. That's all. And so that should take care of everything. Oh, and then I got to do my using namespace STD. Okay, so there we go for that. Help us out. There we go. So everything is now happy. No more green squiggly because it's been defined over here. Where is it? There it is. All this hard work here. And so what I want to do is just basically print out the XY coordinate and its radius. And then just return back. So your goal as a developer for the print operator is basically to just be minimalist. Give you the smallest amount of detail. Don't give me a full page ad. Don't blink. Don't do anything crazy. Just give me something easy and something that'll print nice and neat. So we're used to using cout, but we're going to use OStream because realistically, well, the reason why we use OStream and not cout or anything like that, we could actually use this same operator to pipe to the console window, to the screen, and then also like a file or anything else that's streamable. I can do this without having to rewrite the code. So I can say, okay, OStream, why don't you print out the opening curly brace, or not curly brace, parenthesis. Then why don't you give me, and because this is where things get weird, and there's no reason to go into too many details, but because this thing has to be what's called a friend function, this thing isn't truly a function that's like a true member of Circle. And so this means that it's in this weird land between a global function and a member function. It's a friend function. And that means that a friend is what you think it means. It means that I'm trusting that as a friend, I trust that you can use my internal data so you can override the privateness of everything here and you can access stuff publicly. So I can't publicly access X, Y, and Z normally, but I've allowed friend access only to this specific operator, and that's it. And so I can actually go ahead and print out the X value from that object, and then print a comma, and then go ahead and print the Y value, then print closing curly brace and radius equals, and then print out the RHS.radius. And I can do that. And then, should I do an end line? Yeah, why not? Well, no, I would say best practices says no. That's not up to me to decide. It's up to you on your end. I gave you a minimalist. I gave you all the details. And if you want to continue on the same line, that's your call. And so this should take care of it. Not quite. There's one little thing here. One little error. This operator must return a value, and it must return oster, the stream object. And I said the reason why it's not const is because you're modifying it by putting information into it. So in this case, OStream has been modified, but the circle has not. We're just accessing its information, so that's why it's const. And now this should build. And so there you go. And that's what it looks like now. Circle dimension is 2.3 comma negative 4.9 radius 4. And if you wanted to, you could do the formatting, because is 4 what you want, or is 4.0? You know, scientific notation, sig figs, all that deal. That's up to you to decide how you would want to approach that. But this now works. And this is just one of many, many different operators that you could apply. So, like, I don't think there's anything here that, like, what would be the... it's just beside the point. We're already beyond a lot of what this course is about. This isn't even in your... it's not even in the course curriculum past just explaining polymorphism and inheritance. So I think this is a good stopping point for this kind of function. Let me go ahead and bring this thing back so we can continue on. And that's how you would, that's your first foray. This is the most challenging one because there's just so much going on. And since you know the hardest one already, everything else comes along pretty simple. Okay, so that is OStream operator. You can see everything going on. And so, again, the friend allows us public access to stuff. Generally, I guess we wouldn't necessarily need it, the friendness of it, because we could just access through all those get methods, the get x, the get y, the get radius. But why not just go right to the source if we need the source here? And that's what friend allows us to do. Let's get to the private stuff without having to worry. Okay, so let's see. There's local scope, global scope, member scope. There's like different scopes now, right? All these different variables come and go. The member variables inside of the objects come and go when the object comes and goes, because it's all a package deal, right? Create an object with all the stuff in here, destroy the object with all the stuff in there. And for those of you moving on to more advanced C++, eventually we'll have to deal with more stuff when it comes to setting up pointers, dynamic memory, releasing memory. There's much more to it than what you see here. We don't need a destructor for this object because we don't have any dynamic memory. But for those kind of classes, we would need something like that. And that all changes all of the different scopes for all the variables, all the objects, all the memory, all the everything. It's just a sea of memory and memory addresses that are just coming and going, and just somehow it all works together. And so, like everything else, it's another big one. I think if I already described it, my apologies. But sometimes it's challenging because, like in this function here, radius is defined, pi is defined up above here, but radius is not defined in the function. You're like, where the heck is this thing called radius? And it's just weird to think that you can access stuff that you haven't seen inside of the function, because I can access any of the public and private stuff over here. And when we talk about inheritance and polymorphism, that even complicates things even more, because now like this radius might be 5 or 6 classes up from wherever you are in your code, the way we set up the inheritance structure. So it can be complicated. Okay, so another new topic here is the idea of a static data member. And so that means it's a different type of variable than the xy radius that you see here for our circle class. And how many, let's see, 3 of these things. Okay, so what happens is for normal variables, just these normal variables, every time I set up a circle object, I'm setting up a new specific xy and radius member variable in memory for each of the objects. So every object gets its own unique x, its own unique y, its own unique radius, and that makes sense because we're not sharing anything like that. But occasionally we want to be able to share the fact that we like a specific variable. And the best example for something like this is to show like a reference counter. How many objects of this circle class exist in my program right now? And you would expect before the program starts it would be 0, and then it could be 1, and then it could go down to 0, and they said it just comes and everything kind of comes and goes, right? And so what we can do is try to set up things to associate ourselves with these static members and these static member variables. And so there's a huge difference between the things that are local to a specific object and the things that are, we call it global to the class. You can only access it as a member of the class, but inside of there, everybody shares it. So that's pretty cool. And so let's just kind of go ahead and set everything up. So I'm going to set up a static int over here, and we've talked about static in the function video about how you can set up a function that has memory by using a static variable, and it's kind of the same deal. It's just it's static. It's a variable that's shared and has memory across all objects of its type. So I can call it count for how many objects exist as when the program is going. And so you're like, well, how about what do? I just go over here and I put count 0, right? Like, no, it doesn't. That's not how things work. What does the error say? Count is a non-static data member or base of class blah blah blah. And so we have to define this thing differently than we do all the other variables because it's a different type. It's a static variable. And so by doing this, you do this up here and you say, okay, I have this type. It's called int. You don't put the static in there. Okay, so notice it's circle colon colon circle for this function, or circle colon colon getx, which is this function getx is a part of the circle. It's the definition for this. And so we need to define this static variable. And we do almost the same way. I say, okay, this thing, I'm using circle as my object. I'm taking count, and I say equals 0. So this says, okay, the circle variable, member variable, static member variable of the circle class is going to start out equal to 0. And what happens is that all the static variables in your program are initialized before even the first line of main is ever called. So you can guarantee that when you hit main, these things are good to go. They're initialized to the things they need to be set to. And so this should build at this point and link and everything else. Okay, good. Without this, will I get a weird error if I don't include this? Probably, maybe not. Oh, I guess it doesn't. No big deal. And so now I have to go in and kind of retrofit everything to accommodate this static variable. And so now I could use a destructor, because only for the reason being that, here, let me just define it first here. Let me pop it in. Okay, there it goes. Wish it wouldn't show it. There we go. So because over here, in this nothing here, now becomes plus plus count, because I'm now constructing a circle object out of thin air, right? And so now, if there were 0 circles a minute ago, I create a new circle. Oh, there's 1 now. And if I destroy something, I go, nope, I'm subtracting off. And that's all we kind of need the destructor for this case, because of the fact that we're just trying to maintain the count, the exact count for how many objects exist at this current time. But that's pretty much it when it comes to this. So now I can supply functions to basically a get. I'm not going to have a set. That's not fair to just let someone set the number of instances. What does that even mean? But if I want to get it, I can do so. And I can call it as a static function. Those of you from C++, you know what that is, because everything is object oriented in Java. And when you go ahead and need like the math operations, cosine and all these, they need to be part of an object. But I don't want to initialize and create a math object to do so. So I use a static function, math dot, or math helper dot, or whatever those things are. And so it's almost the same idea. And so, what is happening? I guess static, you can't have static consts. Fair enough. Okay. And so and because I'm trying to access a static variable, I can only access it statically, which means you'll see when I try to use this thing in a couple minutes here. And so let me define this thing. And the definition is easy, just return count, right? It's just like every other get function. Where did it go? Down here? Yep, there it is. Return get count. And so we're good to go on that front. Everything seems to be working, and now it's just a matter of using the thing. And again, you have to be careful between static and non-static, and maybe this isn't the time to go into that level of discussion. This would be for the next class. So how could I use this thing? So I could go ahead, you would think I could be like c dot get count. But that's the interesting part about this is if I don't have to have an object, like I don't have to have the C existing in order for me to go get the count, because theoretically I should be able to ask how many circles exist, and somehow I should be able to get a response of 0, because there's no guarantee that I have a circle existing. And so I changed the way I reference this. I don't have to do C dot, I do circle. You think, what about circle dot? You Java people, right? Circle dot. Like, no, you do circle colon colon. And so if I printed out this information, I should get 0. And then if I create the circle and then print it again, I should get 1, right? That makes sense? And they're exactly what I'm talking about. I get a 0, then I get a 1. And then what happens? How do I kill this thing off, right? So that's the interesting part too. If I just curly braces, right? These things kill these things off. So if I print outside of this thing, now you get 1, 0 to start, 1 after created. It does its job, hits this closing curly brace. This circle is unscoped and dies, and now the get count is back to 0 again. That's because it called the destructor, and it so it's maintaining a correct value for how many objects exist in the scene at the given time. And that's all I'm trying to get across in this specific video here. So static membered functions can only access static data, because technically, again, if I'm trying to access a static data member, there's no guarantee that an object of that type exists, because I can have 0 objects. So if I wanted to access anything part of the class, I'd have to have an object existing in order for me to do that. And so the reasoning, again, this is the main reason I've seen. Occasionally I'll use this for other things, but generally speaking, no, nothing to worry about. Okay, so now on to the bigger topics of polymorphism and inheritance here. So I am a lazy programmer. We try to be lazy programmers anyway when we do our jobs. we're trying to write the least amount of code to get the job done, right? And that's like everybody else, right? So that I don't have to upkeep more and more and more code that means nothing. So I've been trying to instill in you guys with the way I write my code. So these major topics here, inheritance and polymorphism, is a good way to go about doing this. So inheritance, it's a way to create new classes, new object types. So take circle and take that as a custom or as a base class and say, I want to change it around a little bit so that I can extend it and make it into bigger and better things. And you could, let's say a couple slides from now, you'll see, you can imagine what a circle can be, especially if you have a math background. What can a circle be changed into? A sphere or whatnot. And so, but I still want to write the least amount of code to get the job done. And so inheritance is one way of deriving one class from another. And then once I have this inheritance structure set up, this idea of polymorphism is a way for saying, I want to get the area, or I want to get the perimeter, and like what is perimeter of a surface area? This is where 2D versus 3D does get a little weird when it comes to these names for these things. But what about surface area? What about the surface area of a sphere versus the area of a 2D circle? You know, those kind of things. Or, you know, like, or maybe for a video game, I want to draw things on the screen, but I want to draw different things for different types of objects. And so what I can do is I can set up this polymorphic structure so I don't have to do any more work than just setting up a draw function for each of the two classes, and it just automatically works. And you'll see, again, we're just we're just on the tip of the iceberg with all of this kind of stuff. And so polymorphism redefines how some of these functions might work, and you can make things more custom for different classes as you're trying to customize across the board here. So this circle is a perfect base class because it has, a lot of things use a circle. Cylinder, the sphere comes from that idea. And since I'm talking and thinking, I don't have anything else that comes off, but there are plenty of other things that use circles as a basis for everything else. And so we can call this the parent class, the base class. Every language seems to use a different term for it. And then the derived class, which we haven't touched yet here, is going to incorporate all that data into this. So by setting it up, almost everything that's circle comes for free. Almost everything. Not quite everything, but almost everything. And then from there, we can create extra stuff on top of it. And we're going to need that for get volume and just other things too. And so the children classes can override, but don't have to, override any of the base behavior. So here we go. We have a circle. We have a sphere, which is like a basically, what is it? A circle, just a rotated circle as a sphere. And then I don't like this necessarily because a cylinder is not a circle. Cylinder has a circle as part of its property. So I don't necessarily agree with this, but whatever. Just to get across and that's the fun of programming is if it agrees with your philosophy, you can go and fly with it. Who's to tell you you're wrong except for your boss? So that's just the way things go. So sphere versus cylinder. So don't worry about multiple inheritance. That's the tool of the devil. Java doesn't allow it. Lots of languages don't allow it because it's the tool of the devil. And so we're going to do what's called simple inheritance. We're a derived class. We're going to do the cylinder class. It only has one base type that it derives from, and that'll be class circle. And so we can draw out hierarchies like this. I'm used to drawing it the other way around, where everything comes down. But a minivan class can be a truck. A car can be a minivan. A truck can be a minivan. Oh, that's multiple inheritance. Oh, God, just forget that stuff. So we're going to use the cylinder class here. And so let me just say, okay, let's just start. Let's say blah, 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 all this stuff. Let's just talk about it. And as I talk about it, all these slides will just kind of fall into focus here. So I can minimize and almost get rid of all this stuff. So I'm going to create a new file here, a new header called cylinder.h. Okay. And I'm going to say, I have class cylinder. Okay, just to get things going here. Okay. I'm going to have my public stuff. I'm going to have my private stuff. Every class gets that. And so, but what I want to do is say, I am going to override, and I'm going to be a child class, and I'm going to be a child class of the circle object. And yes, it comes up as this, so I need to include the file. I need to include circle.h. There we go. And then now everybody's happy. And just by doing this little bit, almost every part of circle.h comes along for free. Isn't that crazy? The only things that don't come are the friend operators and the maybe static maybe, and then constructor destructor. Every class has to have its own constructor and destructor. Okay, so you'll just see as we go here. So now what comes for free with the circle then is the x position, the y position, and the radius. That's what comes for free. And so, and everything else that I would need, I'll have to just jam it on Frankenstein style myself. And what I need for that then is the height. Right? I've got an x, a y, a radius, and now a height that can help dictate everything else. And so right now, just to kind of get everything up and running, I could use a constructor, and I could use, I don't need the destructor, but I could definitely use a constructor to make this thing work. Cylinder. And now, what do I supply, right? I supply a double for the x, a double for the y, a double for the radius, and then a double for this, and then a double for the height. So this one needs 4 parameters to get the job done. Okay, I'm almost, yeah, I don't need this anymore, so we can kind of get rid of that. Okay, so now I have this cylinder constructor, and I don't need a destructor because I'm not doing anything fancy. And so now, what do? I need to define this thing. There it is. Okay, let me just save that. Open it up, cylinder.cpp, bring it, drag it over here. I like to put the CPPs in one of these sections and the .h's in the other. Just my thing. And so now what do? This is already giving me an error. No default constructor exists for class circle. And that means that, you know, because this constructor has to fulfill the parent's constructor, which I've created, which in the circle class, which is the x, y, and the radius. And so to do that, that's the first thing I have to do, and I have to use it in the initializer list. So if I have to use the initializer list, why don't I do it, you know, in a nice, normal manner and say, okay, I need to call up the circles constructor, and I'm going to pass along the x, the y, and the radius. Because that's what this constructor requires me to do to fulfill that part of the contract. So the circle part will maintain x, y, and radius for me. And then now what I can do here is say, okay, the height, let me just go, where's my, there it is, there's my height. That will take the height. And then this is a nothing here again. Even it's weird, right? Even though we've done so much, nothing goes into the body of this cylinder. But I know this looks complicated, and again, this is just an introductory lesson for this kind of stuff, but that's all there is to it, is that I need to call up the constructor for the base class to fulfill all the portions of the base class, because again, my contract is when the constructor ends, everything has to be initialized to a valid state. And so the circle can be initialized by sending up x, y, and radius, these 3 guys, and then I can fulfill the height on my end, because that's my responsibility to maintain in the cylinder, by then following up and fulfilling, like if you want to think of picking up the spare, you know, in bowling, like pick up the last pins of what is left over to make everything, you know, to basically knock everything down and make sure everything is in a good spot. And again, this gets confusing because I have height here in one class, I have x, y, and radius, and even this count in another one. And so I don't need to worry about this because the circle constructor will increment the count for the static variable, and so it'll still maintain everything. And that's what's kind of weird about it, right? Like if I want to know how many circle objects there are in my program right now, that also incorporates how many cylinders there are. And so that's why I was saying, is a cylinder truly a circle? And so at a certain point, a lot of these analogies break down when it comes to the way we organize the world and try to create these hierarchies in our brains for the world, and then also in programming code abstractly. And so, okay, but that's the constructor, and now the destructor is not needed. Okay, but then we could probably use a get and a set function here. So we know how to do this. It's a void function for set height, and it's double for the height, since we're doing this for all the other data types. And then I want to also do the get. And doesn't require anything. Okay. And then I can go ahead and set up their functionality over here. And again, that's the easiest stuff ever, right? Height equals height, or return height. Okay, so that essentially covers just basic inheritance. Everything that is part of the circle of this thing is contained in circle, and everything else, which just means taking a circle and I guess expanding, extruding, pulling on it, whatever it is, that is part of the cylinder portion. And so now what things change, right? Let's talk about that in a minute. We need other functionality. Let's just pop them in here for right now. The area, perimeter, volume, all of these things, right? There's no such thing as a volume for a two-dimensional shape, but there is for a three-dimensional shape, obviously. But this area could be the surface area. The perimeter could be, well, maybe what is the perimeter? Maybe we'll undefine this or something. Maybe there's a way to say that we don't want to, to define a perimeter for a cylinder. Because what would that even? Because what would, I don't know, two circumference? I don't even know. I'm just saying. But that would be up to you guys to decide. So let's just pop these in and just go, yeah, I'm going to need to override this behavior. But let's take a minute to see how. Okay, so there we go. So we did a lot of the work here. So there's another keyword called protected. And so what happens is, there's public and private, and then now there's this keyword called protected. And because I know that the circle class is going to derive and is a base class, I probably should make my private information protected. This isn't always true. I generally don't believe in this kind of thing. But this means, the protected keyword means it's somewhere between private and public access. Public access means anyone can touch this at any time. Private means only I can touch this inside when I'm talking about myself in my definition. Protected means myself and any class that derives from me can access this information, whether it's a variable or a function call. And so just say, like, I probably don't need it because I have all the gets and the sets and I'm doing all sorts of crazy extra stuff that I probably don't need to do. But in this case, it's smart to use protected just in case I need to get in and just directly access the base part of my object. And so, whatever, don't worry about that, don't worry about this. So, yeah, when it comes down to it, again, double, x, y, and radius are part of circle, and then I slapped in the height on top of it to make this, I like to call it Frankenstein's monster, because you could just take all these different cartridges, slam them together to make this whole new thing, and it has its own behavior, it has default behaviors from everything, but then I can go ahead and kind of resculpt what I need to use to make things more custom. And in this case, to make the cylinder more custom. And so this is where the idea of virtual functions comes in. So remember, now we have a 3D object that is starting off using a base class, which is a 2D object. So the get area and the get perimeter functions are already part of this, part of circle. They already have a definition, but we're going to change that definition, and then we're going to also include the get volume for cylinder just to change things up a little bit because it's part of the cylinder class, the volume, because now there's no 3D-ness to this idea of a circle. There's no volume to a circle. It's a 0 point. And so what happens here is when we know we're going to have a function that's going to be overridden by other classes that are deriving from me, we call that a virtual function. So these are virtual. The get area and the get perimeter. And so what we do is we make them virtual, and when we do that, I'm just going to say it outright, just say you make the destructor virtual. Okay, there's like, why was that error? Nope. Okay. And so whenever I'm using a virtual function, I make the base class virtual. I guess you don't have to worry about it for cylinder again, because once it's virtual, everything is virtual. But then what this is saying here is circle is a base class. Circle can have a definition for its function, for what it does, how it generates its data, how it generates its area, how it generates its perimeter. But at the end of the day, that other classes, when they derive from class circle, are free to go ahead and override and change it to suit their needs. And so we're going to need to do that here because we're going to take this over. And then this one doesn't need this because this is completely new. These other functions don't need them. Nothing else is being overridden, right? The x, the y, the radius, there's no reason to redefine these things anywhere. They're already defined. We're perfectly happy with them. You can't do this with constructors and destructors. Can't do this with friend functions. I probably can't do this with static functions. But at the end of the day, okay, but we can do this with just normal everyday functions. And so now in cylinder, we can say virtual, and then we can say this is new. You can put override, I believe. Maybe let me make sure I have the order of this correct, because after a while there's a lot of blue. Okay, nope. Oh, that's just because I haven't defined these things yet. Okay, but anyway, coming back, so I'm like, okay, I have all these things. There's an override, and this is just saying that yes, it just helps the programmer understand that yes, you're going to find an overridden definition for how to generate a perimeter, how to generate an area here. So let me go ahead and set this thing up. Okay, so here are my three functions. And so I actually looked up, I think it's kind of weird that there is a function definition for the perimeter of a cylinder, and it is 2.0 times the radius plus the height. Let me make sure of that. All right, so I was wrong. Turns out it's 2 times diameter plus height, not radius times height. So that's 2 times whatever, right? So let's just put it in there. 2 times radius. Okay, I'm not going to worry about it. We can make it look nicer later. 2 times radius, 4 times radius, right? Plus 2 times height. And I think that takes care of the perimeter. And then I can look up the area of a cylinder. That's the surface area. And I know the volume is 4/3 pi r cubed, right? So 4.0 divided by 3.0, 4/3 times pi. Do I have access to pi? No, I don't have access to pi. That's the fun part of having that global variable back here in the circle file. So what I can do then, instead of doing all this, is I can move this around, and since this is probably needed, I can go ahead and move this over into here, and just say it's a protected constant. I don't think that changes anything else here. Nope, so far so good. And so then I can go back here. Where is my cylinder down here? 4/3 times pi times radius times radius times radius. And we could do some experimentation to see what's better, 2 multiplications or the general use power function. And I would think maybe 2 multiplications would be faster than a whole loop structure and all the crazy stuff that's going on under that hood to generate that power function. And so 4/3 pi r cubed. Let me make sure that that is exactly right, because I'll hear about it forevermore in the comments section if I don't have that right. 4/3 pi r cubed. Yes, Brad. What is wrong with you? Yep, we figured it out. This is a sphere. My bad. So the get volume is pi r squared. So pi times radius times height. I make mistakes all the time. Okay, so pi r squared height, because you take because the volume of this thing is just the area of the circle times the everything else. And if I wanted to, then if I know that much, I can actually say circle get not radius, get area, which is kind of cool, right? Or I could just say get area, because no, I can't use it for this one. I can't use it for this, so I can say for the circle, because I'm overriding the area, I'm going to do surface area next once I get my head out of my butt. And so, okay, so perimeter is all set, and the volume is, okay, get me the area of a circle using my parameters, and then multiply that by the height. Because if I just said get area, the way this would work out, it would call this function, and then it wouldn't work out right, because then I would get the surface area of the cylinder times the height, as opposed to the area of the circle that came out. Okay, so then that's, so let's take a look then finally to finish up the deal. It's been a full year since I thought about this stuff, I guess, is what is the surface area of a cylinder? All right, so after 1 minute of research, I have come up with this formula. The surface area of a cylinder is equal to 2 pi r, the height plus the radius. So we can just go ahead and do that. So 2.0 times the value of pi times the radius times the value of the height plus the radius. That I am going to go with. And if it's wrong, fix it. You don't really have to let me know. It's fine. It's just getting the point across. I'm not using this for anything. I'm just using this for a demonstration. So yes, I would definitely test this more than the 0 testing I'm going to do. But now what's cool about this is, with all this working, now I have to use pointers and I have to use all sorts of crazy stuff to get this thing to work. And I'm going to just cut to the chase and just get this thing to work for you and show you how to get it going. For cylinders and circles both working together in peace and harmony. So you can see a lot of little things going on here. So if I say, okay, what's the area of C, which is my circle? If it's just a normal circle object, then you'll see it's pi r squared. R is 1 here, that's whatever, so pi r squared, that gets me 3.14155. Pi. Cylinder, pi r squared height, right? Let's see, pi r squared, where's this guy? 1 here. Oh, area, I'm sorry, we're back to area again. Oh, geez Louise. Surface area, so that's that other crazy function of 2 pi r, so like 6 times this plus that. Yeah, so that's about right. So I'm just saying, but it's calling the correct function, right? That's the cool part of the polymorphism here, is that it knows which, it's calling the same name, but it knows which version of the get area function to call. Because it knows it's a circle, because it knows it's a cylinder, it calls the correct function and does the correct job. And that's pretty cool. But now I say, like, for these kind of situations, yes, this is perfectly normal. But let me just set you up with one more last situation before we call it a day here, where things don't work out like you expect them to. All right, so I wrote some code here for you, and what you see here, the bottom stuff is what we've already done. And so the circle gets drawn out with its gets area, its cylinder gets drawn out with its get area, and now I set up a vector, which is a smart array. Those of you who haven't, whatever, it's no big deal on that. But I just made up a two element vector, a 2-element array, and I did of circles. And see, one of the things here of object-oriented programming with inheritance is this thing of an is-a relationship. Because, you know, just like a bee is an insect, you know, like I am a professor. All the way these hierarchies work, I can fill, you know, so I can fill, like a banana is a fruit, orange is a fruit. And I say I can group these things together, and so I can say a circle, because I set up the way things the way I did here. This says cylinder is a circle. That's what inheritance means. So I can actually set up a vector of circle objects, and even put into them a cylinder object, because of the way we've set everything up, and say cylinder is a circle. So that fulfills the object's goal of being a vector of circles, because it basically fills in the gap. Just like saying I could have a handful of fruit, and I could have a banana, I could have an orange, and whatever else I can hold in my hand or 2 hands. So I can have a whole collection of fruits, but they're all different things. And that adds complexity that is not part of this course. But the thing that goes wrong here, by setting things up the way I did, this brings everything, I'll say it, full circle when it comes to our understanding of why we need pointers and why all of this inheritance and polymorphism works out. And so running this code, you will see that this was our stuff from earlier. The circle was 3 something, the cylinder was 25 something. But what you see here is with a circle and a cylinder inside of this vector, when I call get area, it only gives me the same value twice. It doesn't do the correct value for the cylinder, which is the exact same stuff I did down here. And this just comes around. This is just fun. This is just how C++ is. And so what happens is, it's this idea of what happens at compile time versus what happens at runtime, when the compiler and the computer and their program is trying to deduce, what are you trying to access? And so when I don't use pointers, and so when I'm not using pointers for things, everything is static, meaning at compile time. So there's no way at compile time with a vector of circles that the compiler is going to know on a case-by-case basis what the heck is in its collection. So the best it can do is print out the circle version, because that's what it says that these things are. It uses the circle version of the get area function. So that's where this is going horribly wrong for us. But then now to fix that, if I use a vector of circle pointers, that does the first part. It always turns red when it doesn't. And okay, so because these are supposed to be circle pointers, if I dynamically allocate these things instead, and say, okay, circle pointer, and I'm just rushing to the finish line at this point, but I say C arrow and things like that, because again, this is just above what you guys need to know. But just to say the syntax changes, but now because I'm using pointers at runtime on a case-by-case basis, it will decide and figure out which get area function to use. And since I have virtual functions already defined and I'm using pointers, you will see now that it all comes together and I get the same two results for the same two things and everybody's happy. So it's why do we need pointers? And why do we teach it? Why do we have to have it? Because Bjarne Stroustrup said so however many years ago when he was advancing C into his own language. He probably could have got away with it, but he wanted his language to be different than pure C. That's my working theory. I haven't done much research into that. And so newer languages, Java, C#, Python, there's no idea of the pointer. There's the idea of the reference. And that's, but again, almost completely accurate statement to say a pointer is almost the same as a reference minus a few rules. And so that's why we have to make pointers. So I say we show you these things in Chapter 9, and then we just go crazy on them in advanced programming, advanced C++, because to make anything of substance and to make everything work with inheritance and polymorphism, all the powerfulness that comes with that, I absolutely have to use pointers. And that means I have to, basically have to new up memory, and I have to be the master of newing up and deleting and making sure there's no memory leaks in my program. And so thank goodness for C# and Java and Python and all these languages that have garbage collection and all these kind of things that just maintain all this stuff for us. It's so much nicer than having to do it ourselves in C++. But at least when you do it in C++, you get a better understanding of being a better programmer, because you understand all the little details that kind of get swept under the rug when you're working with a high-level language that does all that automatically. And like even in this case, there's a memory leak right now because I newed up memory and I'm not deleting it. I'm going to leave it. Oh, well, I might as well. You can either fast forward or not even care, right? So for every circle pointer in circle pointer C and D, delete C, and then just for the sake of this be not clear, just be nice. I don't have to, but there we go. So that will take care of that. For every circle pointer that is in my vector, delete whatever is pointing at and then clear out the memory. So that takes care of that issue. Now I'm a lot. You wouldn't notice that you wouldn't notice the memory leak. And even in like the video game stuff, it was the worst bug ever that would come in. The bug report would come in from the testers, and it would be that bug. It was the worst one ever because it was like, well, how do you get this? How do you get the program to crash? You run the game for 67 straight days, and then it crashes. How in the hell are you going to figure out a memory leak that takes 67 days to kind of find, to come to a head? And so it's crazy. But in this case, usually, almost always, every new gets a delete, and then you don't have to worry about everything. But you got to make sure you new up before you use it, and then delete it after you're done. And that's the general rule. And again, you're more than welcome. All my YouTube videos are available, so you're more than welcome to jump right into the Advanced C++ lectures and just go to town on those if you want to understand more details about what I'm trying to say. So that pretty much covers what I wanted to talk about. That's it for the lecture here. Just talking about virtual functions and whatnot, and there's pure virtuals. Again, there's much more when it comes to what we're talking about. This is just the tip of the iceberg. And then once you understand how to even do it, then you have to start thinking about architecture. How do I set up all my objects so they can work together appropriately? And that's engineering. That's software engineering in a nutshell, as opposed to just being a pure programmer. Okay, but again, that pretty much covers everything I wanted to talk about at this introductory level when it comes to the more advanced topics of classes, which is operator overloading, inheritance, polymorphism, and virtual functioning. So as always, swardb@cod.edu is a great way to get a hold of me. And otherwise, you can leave a message here on YouTube. And so does this cover? I believe this covers it for the engineering students. So well done, you made it to the end. The final videos of this is just kind of like a quick review of the first 9 or 10 chapters. Quick meaning 2 hours as opposed to 10, 11 hours of however many hours of videos I've made. So it's one of those things you can go back if you need a quick refresher as opposed to the more lengthy refresher on how to do these things. Then by all means, at any time, use any of my videos however you see fit to get you to understand programming a little bit better. So thanks everybody. Thanks for sticking it out with me. Have a great day. See you next time.